Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, and thank you for watching IT Pro TV, helping you level up with IT learning everywhere you go. I'm your host, Zach Memis, for this episode of CompTIA Linux Plus. We're going to be securing apps with SELinux. Sounds like fun? Yes, it's going to be fun because Don Pizzette is here and he's going to help us out. Don, good to see you.
Hey, glad to be here, Zach. And you mentioned we're talking about SELinux. That stands for Security Enhanced Linux. And as the name implies, it's a security subsystem for Linux that allows us to really lock down the access that applications have. And that's a super cool thing to do. So in this episode, we're going to learn a little bit about how SELinux works. We'll see if we're already running on our system, kind of learn about how to configure it, and how to make sure that our system is as secure as possible. So that's all coming up right here in this episode.
So you teased it a little bit, but what really is SELinux?
All right, so SELinux is one of those really neat technologies that didn't come from the regular open source community. It came from an odd source. It came from the NSA, the National Security Agency here in the United States. What happened was basically when a system gets compromised, right? Usually an attacker will find some kind of vulnerability in one application. And once they've broken that application, they can gain elevated rights on the system, and then they have access to everything. Like once they're a root user, that's it. The walls are off. They can go and do whatever they want. Well, at the NSA, they needed secure servers, and they wanted other people to have secure servers too. And I know some of you are chuckling because it's the NSA, but they wanted to have systems
out loud.
they could trust. So what they did is they created this system that basically put walls around everything an application can do. And it just said, hey, even if you're running an application as the root user, the application's only allowed to access certain things. And they did this by setting up some mandatory access controls, basically some entries where we label everything. Everything gets labeled. And if an application is trying to access a file that it's not labeled for, or a TCP port that it's not labeled for, or a section of memory that it's not labeled for, then it's not allowed to do it. So now if a hacker breaks in and compromises a single app, they might be able to elevate their privileges within that app, but they won't be able to leapfrog through to the rest of the system. And that's a great thing. And if you want to learn more about the origins of all this stuff, let me bring up the webpage here. You can view it. It's actually on www.nsa.gov. And it's one of their research projects right there under the What We Do and Research sections, SELinux. And so they write all about it. They created it for themselves, and then they open sourced it. They released it out there into the community, and now we can all use this. And it gives us super fine-grained controls. Now, you've already seen our episode on file permissions, where we can set if somebody has read or write or execute. Well, here it goes even beyond that. And it just says whether or not an application is even allowed to see the file exists in the first place. Better yet, read or write or execute. So it's super, super specific in the way that we write the rules and we customize things, and that gives us a heck of a lot of power. So really cool stuff, and all available for free.
What does SELinux do when it detects inappropriate access?
It kind of depends on what we want to do. With SELinux, it's got three options. All right, so one option is it can be disabled. We can turn it off, which means you might as well have it uninstalled. So it doesn't do anything, right? Unapproved access is allowed, and that's it. All right. Another option is to set it in what's called permissive mode. In permissive mode, an application is allowed to access things that it shouldn't be accessing, but a log is kept that keeps track of that. All right. Now, that doesn't sound like a very useful thing. But let me tell you where permissive mode is really handy. If you're testing out an application, maybe it's an application you wrote in-house, you might not have good documentation that says exactly what directories and what network ports and so on that application needs. So what you can do is you can put SELinux in permissive mode, run the application, and every time it touches something it's not authorized for, it'll be in the logs. And so you can look at that and say, okay, I need to add access for this, this, and this. And then you can approve those things that you know are safe. And then you can flip SELinux into its third mode, which is enforcing. In the enforcing mode, if an application tries to access an unauthorized resource, there's a log message that's created and the access is prevented. And so it's blocked. So you can lock your application down to just what it needs. And then if an attacker tries to get it to do something extra, or a bug tries to do something extra, it gets stopped. SELinux blocks it. So those three modes are really handy, and you can shift between them. Disabled, you might use that if you're troubleshooting, right? Something's not working on the system, and you're wondering, is SELinux the problem here? you might disable it for a moment, test the application, see if it works, and then re-enable SELinux. If the problem still existed when SELinux was disabled, you know that's not the problem anymore, right? Now, the reality is you shouldn't even have to disable it because you can just go to the logs and see if SELinux did anything. So disabled is probably the least frequently used, but permissive is super handy for building apps. And then enforcing is where we want it to be most of the time, where that access is actually prevented.
So how do we get started with configuring SELinux, Don?
All right, well, the first thing we need to do with SELinux is to make sure that we have it, right? Most distros either support it, it's in their repository so you can download and install it, or have it already installed and active. So if you're running a Red Hat-based system, like Red Hat Enterprise Linux, CentOS, or Fedora, they all have SELinux installed and running by default. If you're running Ubuntu, it's not installed by default, but you can install it from the repositories. The package is just called SELinux. And then there's the policy tools that go along with it. But if you just grab that base package, SELinux, it'll pull the other things along with it too. You can test real quick to see if you've got it. Here, let me get out of this web browser. And I'm going to fire up a terminal. And one of the easiest ways to see if you're running SELinux or not is to just run the SE status command. Okay, that's the security enhanced status command. And that will give you a quick rundown of whether or not you're running SELinux. If you get the command not found, right? If I were on an Ubuntu system and I ran it, it would say command's not found, but it's part of this package. And it would then point you to that SELinux package to install. In my case, it's already installed. And so it says SELinux's status, it's enabled, it's turned on, all right? And it has a special SELinux file system where it stores its policies. And that's mounted right now in /SELinux. And I can see my current mode is set to enforcing. So I'm enforcing the limits right now. That's the default on all the Red Hat-based distros. Now, notice this next line here, mode from config file, right? When your system boots up, it has one setting. That might be different than what you're running in right now. That's why I have these two entries that says I'm configured to be enforcing, but I'm actually, well, enforcing. But I might have temporarily changed it. Remember I said you could like temporarily disable it? So my current mode might be disabled, but mode from config file might be listed as enforcing. So you may actually have a difference there. But that's kind of a quick look right there to see, all right, I am running SELinux. It is doing something. If we want to change the status, like, or what's going on right now, like I mentioned disabled or permissive. If I want to flip to one of those modes, there's a few easy ways to do it. It depends on if you want it to be permanent or temporary. If I just want it to be temporary, I can use the set enforce command. Set enforce lets us modify what SELinux is imposing. Now, pretty much every command I'm going to run for the whole rest of the show really needs administrative privileges. And so we need to sudo a lot of these things. If you want to change SELinux's role, I would need to do a sudo set enforce. And then I would need to specify what I want that enforcement level to be. I could set it to disabled. I could set it to permissive if I wanted. And they also have numbers assigned to them where like 0 is disabled, 1 is, actually 1 is enforcing, 0 is permissive. I don't think disabled actually has a number. So I can type it by name or number if we want. If you forget the numbers like I'm forgetting right now, we can pull up the man page and see it there. I'm just going to run sudo set enforce permissive. And if we do a man set enforce, right in here, it'll show us enforcing is 1, permissive is, actually, am I getting it backwards here? No, enforcing is 1 and permissive is 0. So it's right there. And yeah, disabled does not actually have a set enforce command.
Okay.
So that's one way to do it. And if I do an SE status right now, I can see that my current mode is permissive. So I'll allow unauthorized access and just keep a log of it, right? But this is temporary. If I reboot, it's going to load from the config file. So if I want this to be permanent, I've got to go and modify that config file. And to do that, you're just going to use sudo and then whatever text editor you use, maybe Nano, I use Vim. So I'll do sudo vim /etc/SELinux/config. And when you look in that file, and there's no extension on it, the file's just called config, you'll see two entries in here for the targeting type and for the mode that SELinux is in. Mine is set to enforcing right now. If I wanted it to be permissive at boot time, I could come in here and comment out that line, or I could just edit that line, but I like to remember what the default was. And so I could add a new line in here like this. And now if I were to reboot, it would boot up in permissive mode. All right. Now I don't want that. I want mine to actually be enforcing. So I'm going to just set that back. I'll leave this commented outline, SELinux permissive. If I ever want to flip that in the future, I can just remove the comment. And I'll go ahead and save that. And if I want to put myself back into enforcing, I can just go to sudo setenforce enforcing and do an SE status real quick to check that. Or there's actually another command, get enforce, and that'll just tell you what you're enforcing. So if you're in permissive or whatever, I should have highlighted it back in that config file. We saw that third mode right there, disabled. So I can't just disable while I'm live. I'll have to actually change it here and reboot to actually have SELinux truly disabled. And that's because it hooks into the kernel. It's sitting in between the Linux kernel and all these applications that run, so there's no way the application can bypass it. And that's a big deal. It's not just something that it lets us unload on a whim. We'd have to actually reboot. But once we've seen all that, we know that SELinux is installed, it's enforcing, it's running. You can also verify that it's actually doing something by looking at those log files. I mentioned there's log files, and they are stored in /var/log/audit, that folder right there. Now, you have to be a super user to get into it, and you know what? I'm gonna cheat a little bit, because like I said, pretty much everything I do in this episode, I need admin privileges.
Yes, you do.
So I'm gonna do a sudo-s just to change my shell over to a root shell. If you do this in real life, it's okay, as long as you remember to exit it when you're done, because every command I run now is going to be run as a root user. So if I start doing mundane normal tasks, I'm doing them as a root user, so that's not a great security practice.
No.
So I'm going to go into /var/log/audit, and what I should see in there is an audit.log, and that's SELinux kind of doing its thing. Now, this log file will oftentimes get really, really big, and so we're not just going to cat this file, because it's got tons of stuff in there. We'll normally use something like tail. And so I can do tail audit.log, and it'll just show me the last 10 lines. And see how there's quite a bit there? I didn't actually see how big the file was. But each of these lines is indicating that something happened on the system. And it might have been okay, or it might have been bad. So if I look at like this first entry here, cron D, right? The cron daemon that runs scheduled tasks ran. And the result, whoops, the result is me scrolling around like crazy. But the result was success. This was okay. It was allowed, right? But we may find something in here where it gets denied. Actually, these look like all successes. So I see more result, success, and so on. So each of those are kind of passing. But if something gets blocked, you'll see it in here. And then you can look at it and say, all right, is that something that should be allowed or not? You know, do I need to manipulate that in some way or whatever? And the way it's testing all of this stuff out is by using labels. I mentioned labels earlier. Everything has to be labeled somehow. And there's 3 different labels that identify what that service is, what that user is, and what that resource is that they're accessing. And if the label is unset, you'll see something like what I'm seeing right here, this unconfined U, unconfined R, unconfined T. That means that those 3 labels weren't defined for that resource. So it had no labels, but whatever it was doing was actually allowed, because we got a success here. So that particular service just happened to be allowed to do that, even though it doesn't have a label. If it has a label, it's considered confined, but the label will have a name, and that'll show up here. So like looking up here at cron, I can see system U, so it's got that system label, and then system R, and then cron DT, that data type of cron D. It's allowed to access any resource that's tagged with that cron D label. And so in this case, it was doing exactly that. It was allowed, and so it got a success. And you'll see those labels. Well, actually, you kind of don't see the labels. Let me go to my home directory here. When I look around in my home directory, I see some files, right? And they're just files. But they actually do have SELinux labels on them. I did an ls-l. If you add a capital Z to that, that output is going to include the SELinux labels now. Capital Z, remember that one. And I can see each of these are flagged as system U, object R, admin _ home _ T. I'm the root user right now. So these are flagged as admin home. If I were to change to /home/dpossett and look at the directory there, these aren't admin home. These are user home, because that's a regular user directory. That's a different label being attached to those. And that SELinux label is what's being used to determine whether an application has access. And you'll see the same thing with processes. So if I do ps-aux to pull up all the processes running on my system, right? There they are. Well, I can add, oh, you know what? I'm going to filter this down a little bit, try and make this a bit smaller. who's a process I can single out here? Let's take, well, we can take cron D. So cron D is running. So if I grep that for cron D, there we go. So I can see that cron D is running.
Mm-hmm.
If I took PSAUX and added a capital Z to it, just like with LS, now I see it along with the label, right? So here's cron D running, and I can see those labels from earlier, system U, system R, cron DT. Those are the labels that are attached. So processes have labels, files have labels, network ports have labels. Everything has SELinux labels so that we can do fine-grained control.
Well, can you show us an example of configuring a service?
Yeah, absolutely. So my system actually has Apache installed on it. And when you install Apache, the web server, by default, it wants to store its documents in /var/www/html on a Red Hat system.
Mm-hmm.
On Ubuntu, it's a little bit different. But that's basically where it wants to put the data. Well, Red Hat knows that, and Red Hat configured the SELinux policy for this. So Apache is allowed to access that directory. And as a result, I know that HTTPD is running. Well, I guess I could verify that real quick. Let me do a PSAUX. I'll filter that for HTTPD. And yeah, Apache spawns multiple child threads based on what's doing. So I see a number of different HTTPD services that are up and running. And if I were to fire up a web browser, let me go back to my website here. I can browse to 127.0.0.1, and here's my website right on the server. It's very exciting. So I know my web server is working, and it's storing that web page in its default location. If I browse to /var/www/html, there's my index.html file. Now, if I do an ls-l and a capital Z, I can see that index.html file, look at the type that's attached to it. httpd_sys_content_t. So it's flagged as something that HTTPD is allowed to access. And if I were to go to those parent folders and look at them, so I'm looking for that www folder right there, I can see httpd_sys_content_t. So it's labeled right to allow Apache to do it. Now, let's say that I don't want Apache to store its documents there. I want to move it to a different location. Maybe I've got a separate hard drive. I want my web pages on a hard drive or a separate partition that's mounted read-only. And that way, if a hacker gets in, the partition's mounted read-only, they can't modify my web pages, right? There's a lot of companies do this. So I might go and create a separate partition and then bring it online. And when I mount it, maybe I mount it to /website. And so when I mount it to that folder, I mount it read-only. And I'm going to move my index file to that location. So I'm going to move I'll copy it. /var/www/html/index.html. I'm going to copy that into /website. All right, so going in there, I see that index.html. And if I do an ls-l with a capital Z, look at the label attached to it. The label's wrong, all right? Instead of being flagged as HTTPD content, now it's flagged as just default. It's got the default label, all right? And if I look at the website directory that I made, I should see the same thing. Yep, default label right there, okay? So if I go and change Apache and tell it to use this folder, that's a folder it doesn't have access to, right? So if we want to see that, let's go and go in here and edit, let's see, config.d/httpd, whoops. Well, shoot, it is called, I got to remember where the configuration is. If we go into /etc/httpd, it is in conf. There we go, httpd.conf. That's the one I want. So I'm going to edit this file. All right. And I'm going to do a quick, well, I guess I could just find it. I'll look for anywhere it has /var/www/html. And I'm going to change that so that it's pointing to this new directory, right? So this new /website. That's where I want that to be. And there's one more entry, I think just a little bit further down. There it is. And I'll change that one too. So now Apache is going to look to that folder in order to find its web content, right? And so if I do a service httpd stop and start, there we go. So it comes online. So I just restarted Apache so that it would load as config and point to that new directory. If I go to Firefox here, let me open up a new tab, and I'm going to browse to 127.0.0.1, I get the Apache test page. Okay. The reason is Apache tried to read the /website folder, but it wasn't allowed. And so SELinux blocked it. And Apache has a rule in it that says, if I can't find a home page, I bring up the test page, right? And so that's what Apache did. It brought up its test page. So it does not have access to /website. And if I didn't wait too long, I should be able to tail /var/log/audit audits.log. There we go. And we should be able to find HTTPD. Here we go. I can see HTTPD right here trying to access a resource. And earlier we kept seeing the result, res equals success. Well, right here I'm seeing AVC denied, AVC denied. And that's letting me know that it ran what the application was doing against my SELinux policy. It didn't match, and it blocked the access. And it did all that on my own, or on its own, right? I didn't have to tell it anything special. It just knew Apache shouldn't be looking at that directory. So if I want to allow an application to be able to get into that, then I need to update my policy to tell it that it's allowed to be able to access it. And there's a few ways to do that. But the easiest way is if you know what label is supposed to be tied to it, those labels are what are called SELinux contexts. And so I can attach that context to any directory or any file that I want to get it set the way that I need it to be. I just need to know what that context is. And if you use that ls-lz to look at file context or psaux with a capital Z, those will both show you what the label is. So you don't even have to go Googling around or reading a bunch of documentation. You can just look at the process and then assign that same label to the resources. So to fix my website, for example, what I can do is use the chcon or change context command. And I'll just say chcon. I'll do a -R to make this recursive because I want to do the folder and the files inside of it. And then I'll do a V to do verbose, just get a little extra screen output. And I'm going to tell it that I want to set a type. And the type is going to be httpd_sys_content_t. And that's coming right from the ls command we saw earlier or psaux. And I'm going to set all that on /website. Okay. Now, when I run that, there it goes, changing the security context, right? And now Apache should be authorized to access that folder. And if I go and open up a new tab and hope that Firefox isn't going to cache this on me, there we go. I get the Don server. Okay. So even though the Apache service may have had read or write access to that folder, because SELinux didn't approve it in the policy, it wasn't allowed and it was blocked. So that's what we need to do to get it put in place. And now everybody's happy.
Don, you make it look so easy. Now, are these changes persistent?
You know, they aren't. Well, sort of. Hang on, let me clarify that. If I were to reboot, those changes stay there. Yes. Okay. But let me give you a word of caution. Whenever somebody's dealing with a problem and something doesn't work in SELinux, there's a command called restorecon. And what restorecon does is it lets you put a file or folder's context back to what it's supposed to be by the default. There's a security policy that defines all the defaults. And anytime I'm messing with a folder and it's not working, what I assume is, probably the contexts are wrong. And so let me just do a restorecon and fix it, okay? If somebody were to do a restorecon on that website folder, it's going to undo my changes because my changes aren't in the policy. So the changes will stay in effect as long as nobody reapplies that policy. But since that is kind of a go-to troubleshooting command, I want to change the policy to reflect this new setting. Okay, so I need to go a step further than what I did right here to put that in place and make sure that it becomes kind of permanent. Now, the policies themselves are actually pretty hard to write. And there's a whole definition that when you install SELinux or if it's installed for you, the policies are all downloaded. The people at Red Hat, in my case, have already written those policies out, thank goodness, because they're massive. But if it's something little like this, just approving a folder or approving a file, that's actually pretty easy to add in by using the SEmanage command. So what I'm going to do is, here we go. First off, let's see, do I want to try and break this first? Yeah, let's break it. So I'm going to do restorecon. So that's that command that I mentioned.
Right.
And I'll do -RV, just like chcon. And I'm going to do this on /website. And so that's going to crawl over that folder and put it back to where it's supposed to be. See how it just changed it to default? So now it's all put back to how that was. And that's what would break it. So now Apache doesn't have access again. But I can come in and say SEmanage, and this lets us manage our SELinux policy. This is part of the policy toolkit. And I'll just do SEmanage, F context, so I'm setting file context, and then -A, -T, I'm assigning a type, or I'm adding a type, and that's going to be HTTPD, whoops, darn it, HTTPD _sys _content _T, right? That's what I assigned with chcon a moment ago, and I'm going to assign that to /website. Now, when I run that, oh, shoot, I don't have the policy toolkit installed, so let me do a quick sudo yum install. And the package, at least on Red Hat-based systems, is called policy core utils -python. So let me run that real quick to get it installed. Whoops. Oh, darn it. I didn't approve the key. Let me do that again. Job worth doing is worth doing twice, I always say.
And it's live action debugging right here, ladies and gentlemen.
Yeah, I've done this so many times. I've forgotten this package. That's why I have the package name memorized. So once it's done, though, that policy core utils -python, that's what gives us that SEmanage utility. I actually thought it was installed by default on this one, but apparently I was wrong. So it's going to install, and as soon as that's done, I'm going to run that same command. And that's not changing the folder, that's changing the policy. So once that's done, here we go. So now I'm going to run that SEmanage command.
There we go.
And it should succeed. It takes a moment because it has to modify the policy and then compile it. So it's actually a little bit of a process. See how that stalled? It's not that my machine is slow. I've got a pretty fast machine. It's just a big policy that it has to deal with. Once that's done, if I look at that folder, it still has the wrong context, right? Because I modified the policy, not the folder. But now if I go back to where I did restoreCon and somebody were to run that on the folder, now it actually changes it to the right thing. And that's really a better way to do it, because now I know that not only is the context set right on the folder, if I reboot, it's going to be there. And if somebody does a restoreCon, it's going to be there also. I've modified that policy. So I'll usually use chcon just to kind of figure out the right settings. And once I know the right ones, I'll turn around and I'll do I'll do SEmanage and make it a part of the policy to get that permanent. Once that's done, now you're really in business, and it's set.
Well, is there anything else SELinux is capable of, Don?
You know, I focused on files because that's what we normally deal with, but it does ports as well. So if I wanted, Apache is set to run on port 80 and port 443 by default. 80 for HTTP and 443 for HTTPS. Let's say I wanted to run on a non-standard port, like 8080 or something like that. It's not allowed. SELinux is actually going to block that because it thinks, this might be malicious. Somebody's using an application the wrong way. So if I want to allow it to use a port like that, I would need to come in and approve it. And you can use SEmanage. A moment ago I did F context to set file context, but you can say SEmanage port, and you can add a particular type to a port. So I can do HTTP port T, and then I can specify what port I want to give it. So I'm going to give it TCP port 8080, like that, and that's going to authorize that port for Apache. So now it'll be able to use that extra port. And once that's done, looks like it's already defined. I should have pulled up my listing. If you do SEmanage port -L, it'll show you all the ports and the types that are attached to them. So here comes my list. And so if I'm wondering who's got 8080, I can look through this list, and apparently something else already has it. I see 8081. I guess I should have grepped for it because the list is kind of big. So so I might find that there's already a type assigned, and that's okay. I can just reuse that same type. Or it might be in use by some other program. HTTP cache port. Yeah, so it's already attached. Or I could assign different port numbers. So just another thing to think about. There's processes, files, ports. These are all different things that SELinux can manage.
Securing apps with SELinux, another fantastic episode. Well done, Don, as usual. And anything else you'd like to add?
If you're ever in doubt with SELinux, remember that you can flip it into permissive mode and just watch that audit log. A lot of times I'll do a tail-F of the audit log, which kind of follows it and keeps showing new entries as they get put in. And you can run your app and they'll just pop up right there on the screen and you can see what's going on. If you grep against that log for your application name, it'll find just your app because you can get a lot of entries in there. So poke around that log file. It'll be interesting to see what you find in there. But also remember that you pretty much need to have root privileges to do Just about every command. In fact, I think get enforce and SE status were the only two commands that I ran that you can really do without being root. So definitely remember to elevate your privileges.
Thank you, Don. There's so much to learn and so much to love with CompTIA Linux Plus. Make sure you watch all the episodes, take notes, do extra study, because remember, you never stop learning. And inside our course library, there is all kinds of supplementary information to help you do one thing, be even more successful. So check that out too. And tell everybody you know about IT Pro TV. IT Pro TV is binge-worthy. Thanks for watching. I'm Zach Memis.
And I'm Don Pizzell.
We will see you again soon.
Thank you for watching IT Pro TV.